All right, so we're going to solve some more equations today. We're going to start easy and get more difficult. Okay, so since these have the same base, if they're equal, we have to set their exponents equal to each other. So whenever you see the same base, like we do here, here, and no, not here. But on numbers 18 and 20, all you do is you set the variables equal to each other. So the exponents equal to each other. So it'd be negative 3v minus 2 is equal to v minus 2. All you have to do is solve that equation. No logs, not really even calculators necessary, because we're going to add 3v to both sides. We can even add 2 to both sides. We get 0 is equal to 4v, divide both sides by 4, and we get v is equal to 0. Unfortunately, it's going to happen a little bit today, because here we should get the same answer when we set those equal to each other. 2n is equal to negative n. We add n to both sides. We get 3n is equal to 0, so n is equal to 0 again there. It won't be the same on number 20, though, because on number 20, bases are the same. We set those equal to each other. So 2b or not 2b, that is one of the questions. We're going to set that equal to negative b minus 1. We're going to add b to both sides. When you do that, you get 3b is equal to negative 1. We then divide both sides by 3. So we get b is equal to negative 1/3. Okay, now the trick on number 19. Let me go ahead and real quickly erase that because it's not a problem that you don't do. On number 19, we have to try and get the same base. Okay, now that's 4 and that's 64. Hopefully you remember that 4 to the third power is 64. So I'm going to rewrite the 64 as 4 to the third. Now they have the same base. If they have the same base, which now they do, we can set these exponents equal to each other. So it's just going to be v plus 2 is equal to 3. That's the trick, is getting the same base there. So subtract 2, I get v is equal to 1, and I'm done. Now a very similar problem on number 21, because we have 4 here, and that's to the first power, and this is 64 to the negative 3n. So 64 just by itself is 4 to the third, but that's to the negative 3n power. Okay, so if I'm rewriting that 64 as a power of 4, this is what I have. Now this is a power of a power. This is a property from a long time ago, but these two have to be multiplied. So it's actually 4 to the negative 9n, and it's equal to 4, which is just to the first power. They have the same base. Now we can set the exponents equal to each other. So it's going to be negative 9n equals 1. We then divide by negative 9, and we get n is equal to negative 1/9. That's going to be your answer for number 21. Number 22. Now you have a choice here. You do have a choice. You can either get these both to be 2's, the base of 2, or 4. I'm going to go with 4 because I know that 64 is 4 to the third power. It's also 2 to the 6th. Just to make sure you know that. Now, 16 is also 4 squared. So I'm changing the 16. I'm leaving the negative 2x up there. If I wanted to change the 16 to a base 2, that'd be 2 to the 4th power. You get the same answer either way, whether you use 2's as the base or 4 as the base. I promise. So when you multiply those two, you have 4 to the negative 4x, and that's equal to 4 to the third. Now that they have the same base, you can take those two and set them equal to each other. So negative 4x is equal to 3. Divide both sides by negative 4. We end up with x is equal to negative 3/4. And that's what you end up with on number 22. Now, because I need some more room, I'm going to scroll. Okay. So that's 5 to the third, which is great. I'm going to leave that 5 to the third. 625, that is the same thing as 5 to the fourth. So this is actually 5 to the fourth, but that's still to the 3k plus 1. Now it's a power of a power. So I'm going to take this and distribute it. Kind of wild. So it's 5 to the 12k plus 4, and that's equal to 5 to the third. They have the same base, so we can set the exponents equal to each other. So this will be 12k plus 4 is equal to 3. So I'm going to subtract 4 from each side. I get 12k is equal to negative 1. I'm then going to divide both sides by 12. I get k is equal to negative 1/12. Okay. Now, this next one's a little bit funkier, though. I do mean that, even though the answer's kind of round. 125. So what I'm doing when I do this is I'm just putting some parentheses in here. I'm leaving the exponents the exact same, but the 125 and the 625, I have to change. I have to get them into the same base. Now, 125 is the same thing as 5 to the third. I know that just off the top of my head. 625, if I check my chart, is actually 5 to the fourth. Okay? So now what we have here is we have 5 to the third to the 3n, or 3n power, and then I have 5 to the fourth to the negative 2n power. So this will be 5 to the 9n, when you multiply those, power of a power, that's equal to 5 to the negative 8n. So we're going to set those two equal to each other. So 9n is equal to negative 8n. I'm going to go ahead and add 8n to both sides. 17n is equal to 0. Divide both sides by 17. I get that round answer that I said we were going to get. N equals 0. Okay. Now I'm going to be skipping around down here because these are just like the problems we did yesterday. But hey, more practice never hurt anybody. We're going to subtract 3.4 from both sides here, trying to get the 11 to the v by itself. We've done it. That's going to equal 20.1. I think. Yeah, I'm going to stick with that answer. Great. So then, to get the v by itself, I have to take log of both sides. So it'll be log of 11 to the v is equal to log of 20.1. So the v comes out front. So I'd have v log of 11 is equal to log of 20.1. I'm going to divide both sides by log 11. So what you're going to plug into your calculator is log 20.1 over log 11, and you're going to get approximately, that's approximately 1.2514. And that should be your approximate answer for number 25. It's always a hint when it says round to the nearest 10,000ths that you need to use your calculator. All right, you're not going to be able to get that without one. I promise you that. So here we go on the last four. Yeah, here we go. Now, the first thing I'm going to notice on number 27 is that they're both negative. So I'm going to go ahead and divide both sides by negative 1 just to get rid of that. I have 6 to the negative n is equal to 36. Now, you can get these to have the same base if you'd like. Why not? This would be 6 to the negative n is equal to, well, 36 is the same thing as 6 squared. So now I can set those equal to each other. Negative n equals 2. Divide by negative 1. N is equal to negative 2. You get that answer either way, whether you use logs or not. But you have to make sure they're positive first. So that first step is still the same. I promise. Now, number 28, the first step here is subtracting 7 from both sides. So it'd be 7 to the k minus 7. That's equal to 81. Now I have to take log of both sides. So it'd be log of 7 to the k minus 7. And it's equal to log of 81. Now that variable has to come, or the exponent has to come out front. So this would be k minus 7 log 7 equals 81. And now I have to divide both sides by that log 7. Oh, sorry, messed up. It should be log of 81, shouldn't it? Yeah, thanks for keeping me honest, you guys. Either way, I still have to divide both sides by log of 7. When you do that, you get k minus 7 is equal to log 81 over log 7. Now, some people might just want to plug that into their calculator, and then your last step is just take whatever it is and add 7 to it. Either way, for number 28, you should end up with k is approximately, and this is approximately here, 9.2583. You should have gotten really something very, very, very close to that for your solution. All right, let me go ahead and scroll down just a bit more. And last but not